long before the idea of computers. Well, not exactly. In some sense, the term model has emerged in popularity over the last 50 years at the same time as the digital computer. And many times in our field, we talk about models as really being computer models in that sense. But what I want to do is to also contrast other sorts of models with other sorts of media, because to some extent, what's happening in our field, which is a little bit surprising, is that different types of models from different perspectives are beginning to converge. So, for example, we could have a debate about urban models, and I could mean mathematical models of traffic flow or land use, but there might be other people in the room thinking about urban models as being geometric, CAD models in that sense. And it's these two issues, the idea of models as processes, etc., which are beginning to converge with models as representations, geometric models. I like to think that geographic models are beginning to converge with geometric models. So really the essence of what I'll be saying this morning is really talking about different types of models and how these are coming together. I'll talk a little bit about models and computation, because virtual cities, to some extent, really represent computable cities in that sense. And then a little bit about the principles of modelling, many kinds of virtual cities, and then some of the kind of spatial imperatives, the spatial challenges which constitute the development models at the present time. And I just want to identify the fact that models are becoming more detailed. They're beginning to be disaggregated, broken down into detail, and the kind of models that we're working with in cities are beginning to change from aggregate to disaggregate, from static models to dynamic models. And the flavour of the month is the idea of cellular automata models, or agent-based models more specifically, which is where really we're representing every aspect of the city in its most formative detail. Agents are really the atoms, if you like, of the city in this sense. So there's a new wave of modelling which is referred to as agent-based modelling. The other key challenge that I'm going to pick up on towards the end of the talk is the idea of integration. We have many different models of many different aspects of cities, but really to handle some of the big challenges that face us at the present time. So, for example, the challenges of issues about energy, climate change, etc., to some extent migration and demography, these really enormous challenges, we need to be able to integrate different types of models over different time periods and at different scales. So integration is another major challenge in terms of the development of virtual cities and urban models. Last but not least, much of what I'll be talking about, and indeed much of what goes on in this conference, will be really about visualization. With this kind of complexity that we're trying to get to grips with, then clearly one of the main ways of portraying that complexity is in terms of innovative ways of visualizing the kind of complexity in different senses. So visualization will also be a key thing. And then, after I've really developed these ideas, I'll talk about some projects in CASA, which really represent different types of models in that sense, to give you a flavour of how some of these things can be tackled in that sense. And then finally, some conclusions about predictions and how our concept of prediction is also changing at the present time. We're no longer really assured that the sort of predictive capabilities that characterise classical science, for example, which indeed 50 years ago, when computer models were first developed for cities, that kind of determinism, that kind of classical notion that we could actually predict the future in a sense, was really something that was widely adopted. This has changed quite dramatically to notions about dialogue, the relationship between models and stakeholders, the idea that models are used to structure the dialogue to actually inform the future. Okay, so geospatial context. I went to a conference a couple of weeks ago where Mike Goodchild, who is one of the key people in GIS, was asked by somebody from the audience, what does geospatial mean? Because 10 years ago people talked about GIS, etc. People talked about geographic information systems, but geospatial has come onto the agenda. And he gave a very good definition of this, saying that a lot of our technologies really deal with spatial things, that some of the things that you'll hear about in this conference, some of the things I'll talk about, may not pertain just to cities in this sense, or to geography, but they pertain to any kind of spatial system. Some of the techniques that we use, for example, to look at the morphologies, find themselves represented really at the micro scale in physics and also at the very aggregate scale in that sense. Ideas about, for example, spatial structure in terms of something like fractal content, fractal morphology, finds itself equally applicable to the universe, whereas to the shape of cities or the detail of what goes on in some kind of substance, in a sense. So, in some sense, spatial is independent of the world we're in, but prefacing the term geospatial gives it kind of a root. And in this sense, geospatial means geographic in that sense. Now, generally speaking, geospatial issues are all about representation and analysis, which is informing the world with respect to spatial function. It tends to veer to abstraction and simplification in terms of representation and analysis, but it's not modelling per se. If you look at GIS, then in some sense, GIS begins with representing the world and then building functions to analyse the world in that sense, but not actually to model things per se. Modelling is really all about processes. It builds on representation, as we'll see, and analysis in that sense, but really modelling is about prediction. If you have a good model in some sense, then generally speaking, people build models in the same way that they build theory, so not only so that they can understand the world, but so they can actually predict it. And of course, in our context, we're also interested in making that next step from prediction through to prescription or design, in that sense, optimization in this particular context. So, to some extent, the models we'll be talking about are predictive models, if not prescriptive models in that sense. And they're computable in the sense that they're theories which turn into models which are computable, and the kind of media, if you like, for prediction is in the form of computer models, and we'll see in a moment that that media, in a sense, represents what we often think of as virtual cities. So, for example, we've already seen this morning with Professor Silva from the rector of Coimbra University in some kind of virtual context in that sense. Not really a model. It wasn't a model of him in this particular context, although if, for example, he were to project himself or the context was projected into a virtual world, etc., and we could see them in that context, then it would be a model. For example, yesterday coming from Heathrow last night on tap, it's actually the stewardess or the flight attendant did not stand up and actually tell us how to put on the seat belts and how the oxygen mask came down. In fact, it was a movie. It was a kind of virtual movie. It had actually been built in kind of computer media. So on the screen, we watched this movie, which was cartoon-like in that sense. So you could see that it was not meant to be realistic in a sense, but it put over the issues in terms of virtual context. So that's the kind of media that we're moving towards. Now, the virtual context, I've really talked really all about this. In some sense, is embodying, if you like, some kind of geometric, probably geometric context in some kind of digital media in that sense. So, for example, virtual cities in terms of the media are really all about the form of the city in digital terms rather than the processes defining the city. In this sense, virtual cities stress technology and media. They tend to be the media in which models are embedded. So if you like, you can see this talk as being putting together two sides of the same coin. On one side is the virtual city idea, on the other side is the model idea. Now, I'm not going to talk in this lecture about the term that's becoming very popular at the present time, smart cities, which is much more technologically focused about how digital media is being embedded in the very fabric of cities itself. Virtual cities and urban models, in a sense, have a big part to play in terms of smart cities, but smart cities is a much more generic concept, which is more technologically focused at the present time on hardware, software, and indeed the delivery of location-based and other sorts of services using the kind of networking that is going on in terms of the development of intelligent cities, intelligent building. Okay, now let me talk really about, spend 5 minutes talking about models. I mean, much of this is really a little kind of description, indeed, of the kind of elements of models. It's Models 101 in that sense, but let me make a few points. First of all, a model is a simplification of reality. It's an abstraction. It's simpler than the real thing. Now, this is an essential tension. We always lose information when we build a model. And in this sense, it's often less than the representation that we see. The art of modelling is to actually produce a coherent and intelligible form, as it were, in this context, a digital form, which is useful for the purpose in hand. So to some extent, in looking at any model, we must really look at its purpose in that sense. Now, the term model has really become central to our vocabulary. If you go back 50 years, then model was not widely used. Go back before the Second World War, and you'll find that model was hardly used at all in science. Model, in fact, was... there are some examples in philosophy of the idea of models, etc., but really models came out of the kind of technological explosion that began with computers after the Second World War. It came out of the Cold War in some senses, in this particular context, and it represented the idea of translating a theory, a scientific theory, into a form where you could manipulate it in some sense. The notion of the computer as the experimental apparatus or the experimental laboratory in which you could test theory led directly to the idea of the computer model in this particular context. So this play on the word model in terms of the notion of how we use it is really central to the lecture. Let me show you some definitions. If you actually Google, if you type into your Google search bar now, whether or not this is still true, I don't know, because I think these slides are probably about 3 or 4 years old, but back then you could put into the Google search bar a model on the web. And if you actually look at those, I'm not suggesting you try and work out what they are, they're very difficult to see, etc., but you find that there's all kinds of models as representation, ranging from supermodels all the way through to city models, to scientific models, and so on in this context. Model also being used as a noun, but also being used as an adjective in this sense. Drill down a bit further, and this is still in terms of the Google definitions, then we see physical or representational objects, which tends to be our world, persons or occupations. Now,